This schematic shows the various components in the HEUI fuel system. A detailed explanation of the system and its various components follows later in the presentation. The electronic components in the HEUI fuel system are very similar to those used in other electronic unit injection or HEUI systems. However, in the HEUI system, the injectors are not actuated by a camshaft. Hydraulic actuation is used to drive the injectors. A high-pressure pump provides power for the system. This pump draws oil from the pressure side of the lubrication pump and raises the pressure to a maximum of 3,300 psi. This pressure is controlled by the Electronic Control Module or ECM. The hydraulic flow is directed to hydraulic actuators in each injector. Just like the HEUI system, the HEUI injectors are electronically signaled to permit oil under high pressure to move a piston, which then moves the fuel plunger. The various color codes, which identify flow and pressures, are shown here. Actuation of the fuel injection system is accomplished using hydraulics rather than the conventional camshaft actuation commonly found on other diesel fuel systems. Hydraulic actuation offers several advantages compared to mechanical actuation, including the ability to make injection pressure independent of engine operating speed. This capability is especially advantageous in many respects, including transient engine response, cold starting, emissions, and noise control. Put simply, the system is not locked to a fixed camshaft timing lobe which could limit timing advance. The injector can be fired at any point relative to crankshaft position. In the HEUI-equipped engine, the lubrication pump has two functions. It provides lubrication to the engine, and it provides low-pressure charge oil to the HEUI hydraulic pump. The engine lubrication pump has been enlarged to provide the required increase in flow for the hydraulics. The hydraulic pump has a cold start oil reservoir. This reservoir prevents the hydraulic pump from cavitating during initial engine cranking until the lubrication pump can supply adequate charge pressure. An oil pressure sensor is located in the cold start oil reservoir, which is also the inlet to the hydraulic oil pump. The sensor monitors lubrication oil pressure. An oil temperature sensor is also installed in the reservoir. This sensor will be referred to as the hydraulic oil temperature sensor. During normal operating conditions, oil is pressurized between 725 and 3,300 psi by the high-pressure hydraulic pump to actuate the injectors. The level of hydraulic pressure is controlled by the ECM, which signals the pump control valve to upstroke the hydraulic pump. When the engine is running, high-pressure hydraulic oil is available to the injectors at all times. Oil from the hydraulic pump enters the two oil supply passages, which convey oil to the injectors in the two-cylinder heads. Reverse flow check valves are used to prevent pressure surges between the oil passages on opposite banks. This effect can be compared to water hammer on a domestic system. The oil supply passages are connected hydraulically to the injectors by jumper tubes. Oil used by the injectors is released below the valve covers and drains back to the sump through the pushrod compartment. Oil is drawn from the tank through the water separator and the hand priming pump by a gear-type transfer pump. The fuel is then directed through the ECM housing for cooling purposes. The fuel then flows through the secondary fuel filter. Next, the fuel enters the low-pressure supply gallery located in the fuel supply manifolds on top of the cylinder heads. Any excess fuel not injected leaves the manifold. The flow is then combined into one line and passes through the pressure regulating valve, which is set at 60 psi. From the pressure regulating valve, the excess flow returns to the tank. The ratio of fuel between combustion and fuel return to the tank is about 1 to 3. For example, 4 times the volume required for combustion is supplied to the system for combustion and injector cooling purposes. This feature also carries air in the fuel back to the tank. A fuel temperature sensor is installed in the fuel supply system and is used to compensate for power losses caused by high fuel temperatures.